Hello everyone, here I'm back with another lecture and today we are going to discuss the topic that is very simple and also complicated at the same time, that is like vector algebra. Majorly vector and scalar are the two quantities that we have discussed in the previous of years in our life. Okay, majorly vector and scalar are the major concepts that you have to build up to understand the different directions of the any of the forces, weight, pressure, torque, etc. Okay, so vector is basically simple is giving arrow to any of the quantity that has magnitude and direction. Okay, that means magnitude is how big it is, and direction basically means where it is going. Okay, so that means how big the uh, object is, or simple as that, how big the area of that object is, and other thing that direction is where it is going. Where the object is moving towards, or the direction they are going towards, is basically the combination of both of them is called as vector. Okay, how you can just draw their arrow, and how you can just describe that. Okay, majorly what happened is the length of the arrow basically shows the magnitude. Okay, so how big the object is simply shows, like if you have simple as that, if we can consider taken a force as a vector, so 10 newton of force shows the arrow is bigger for compared to the, sorry, length of the arrow is bigger, because of why, because okay, we can compare, just give it from the two examples like 10 newton and 5 newton, and both arrows shows a different measurement. For example, we can just scroll it down and see here. Okay, you can just take it that this arrow is of 5 newton and this is of 10 newton. Okay, simple is that. So the 10 newton is basically have the bigger length. Okay, we can just like arrow length is bigger than the 5. Okay, simple as that. Other thing that we have discussed is basically the direction of the arrow. That is simply shows the direction of the vector as well. So that means the arrow that shows that this is the direction. So that means the object is moving in this direction. Okay, simple as that. A force is basically applied to this direction. So simple, the arrow basically the upward area of the arrow, that is like this, that is basically a small triangle. This shows the direction and complete length shows the magnitude of the vector. Okay, now there are vectors in science that we can basically discuss or describe as basically force, weight, pressure, torque, displacement, velocity, acceleration. All are considered as vector, or all quantities are described in this form. Okay, the other quantities that, or the other concept, that is the scalar. Okay, we can just scroll it up again. So see the scalar. Okay, the scalar quantity basically is the quantities that basically only have magnitude, that has no direction. Okay, so that means quantities like mass, length, volume, speed, those you don't need have, or don't have any directions, they are the scalar quantities. Okay, there is no requirement for mass to have direction, there is no requirement for length to have direction, volume to have direction, speed to have direction. So it only have magnitude, the size of itself. So, but as a biomechanist, as a physical therapist, you need to understand the direction of the force as well, right? So in which direction you're applying the force. So for that concept, you have to understand the concept of vector. So the vector is not complete without its direction. Okay, simple as that. So for example, as I have told you, like 10 newton force, but if the 10 newton force is just, we can say we didn't know the direction, what is the requirement, or what is the force, or where the force is applied. So what basically have the concept of force here. So you need a direction to apply some kind of force to some area or something. So this the area or the force that is applied to some object, it also required the direction. Okay, like some upward, some downward, some side to side, etc. So this can complete the full vector. So if you can just say that 10 Newton force, that is incorrect way. So you need to give it any direction, like 10 Newton force is applied on upward direction. Okay, simple as that. So this is the basic concept of vector quantity. Now the vector composition is very important, like how you can add the vectors of same direction, how you can add the vectors of opposite direction or opposite direction magnitudes are. So we can just see here from this picture to understand the concept of same direction vectors and opposite direction vectors. Okay. So when the vectors are in the same direction, we can basically add the magnitude. Okay, simple as that. So that means if we add the magnitude, the length of the arrow going to be increased. Okay, this length, we can combine that, and at the end we can get the result of the bigger arrow as if we can add both of them, and the direction will remain the same. Same like that, if you can just add the magnitude of like these like arrows, those are in same direction, we can just add the magnitude and get the bigger arrow. Same other for other, we can just add the magnitude and get the bigger arrow. Okay, but when we can add the simply we can say when we can add the opposite direction arrows, we have to subtract the magnitude. That means from this arrow, okay, we can just take this. Okay, from this arrow we have to subtract this, but the direction will remain on the area where the bigger arrow direction is. Okay, because the bigger arrow put more force on that object, so object is going towards that direction. Okay, simple as that. So that means the direction we can get after after subtracting the uh, both the magnitudes basically shows the end result, end direction. Okay, simple as that. And the other example, as you can see here, both are in opposite direction, and you can get the smaller magnitude because we have subtract the this magnitude from this arrow. So at the end we can get the smaller length. Same like that, direction will remain the same, that is present on the bigger arrow. And the other for other as well, the direction will remain same, the arrow becomes smaller because of the subtract component, and at the end we get the result. Okay, now vectors in the different direction use tip to tail method. Okay, majorly what is tip to tail method? I can just give it to you. The example simple. I have discussed with you that how we can subtract, but why we can subtract. Okay, or in what way we can subtract. Okay, so we can subtract in the tip to tail method. Tip to tail method simply shows place the tail of the second vector at the tip of the first vector. Okay, you can just you can just say that. Okay, we can just take both of these arrow. Okay, this arrow tip is placed in the forward direction and the face towards each other. Now draw the resultant from the tip tail of the first to the tip of the last. Okay, complete. Work for any number of vectors. Now tip to tail method shows the resultant vector. Okay, the major concept of basically how you can just add or subtract the vectors, why you have to add and why you have to subtract the magnitudes. You have understand that if the vectors are in same direction you have to add, if the vectors are in opposite direction you have to subtract the magnitudes. Simple as that. And you have to place the arrow in the direction where the bigger arrow shows. Okay, in the opposite one. So simple as that. Majorly, this is the all for today. And in the next lecture, we are going to discuss the vector resolution. That is also the very important concept of vector composition, or you can just say that vector algebra. This is all for today, and bye bye.